Welcome to this video. In this video, we're going to talk about scalar numbers in matrices. And the definition is very simple. It's in matrix algebra. I wrote it here. It says that any real number is called a scalar. So here's an example. Let me see if I can just zoom a little bit. Example 1, we have -2 times this matrix, and in order to solve this, all we have to do is multiply this -2 by all the elements inside the matrix, which that will give us, well, -2 times 3. -2 times 3 is -6. -2 times -4 is +8. -2 times 5 is -10, and -2 times 8 is -16. And that is how you will do this multiplication. You multiply the scalar, which is the number outside of the matrix, or any real number, by each of the elements inside the matrix, each of the elements. So let's go a little bit deeper. Let me move here. Let me see if I can zoom out a little bit more. Here's his next example. It says example number 2. If A is equal to this and B is equal to this other thing, this other matrix, then find the following. We have to find 5 times A minus 3 times B. So how will we do this? How will we do this? I want you to think about how we will do this type of problem. And I'm going to work on it right now. So we have 5 times A is 2, 3, -7, 1, 4, 5, minus 3 times B, well, B is 3, 0, 6, -1, 8, and 2. So how do we do it? Well, first, let's start by multiplying the scalar, or it kind of looks like a distribution. So we will do 5 times 2, that's 10. 5 times 3 is 15. 5 times -7 is -35. 5 times 1 is 5. 5 times 4 is 20. 5 times 5 is 25. And I'm going to subtract that by the product of these three multiplied by each of these elements. Let me just move a little bit more this way. So what is that equal to? Well, -3, this will be, sorry, this is a +3, is 3 times 3 times 3. 3 times 3 is 9. Okay, I'm going to leave that minus there. 3 times 0 is 0. 3 times 6 is 18. And then 3 times -1 is -3. 3 times 8 is 24. And 3 times 2 is 6. Well, now the final thing that we have to do is subtract these values. We have this big subtraction. That will be 10 minus, let me erase this. 10 minus 9, 15 minus 0, -35 minus 18, 5 minus -3, 20 minus 24, and 25 minus 6. And that's going to give us our final answer. We just move a little bit more this way. Okay, so we have 10 minus 9 is 1. 15 minus 0 is 15. -35 minus 18 is -53. 5 minus -3, that's actually 5 plus 3, which is 8. 20 minus 24 is -4. and 25 minus 6 is 19. And here we have our answer. Now, it is good to learn this, but we learn best when we practice. So what I want you to do right now is take a look at these matrices that we have seen before. Okay. And I want you to work on these two problems. They're quite simple. Pause the video, work through them, and then click play so that you can check your answers. Okay, hopefully you pause the video. The first problem is quite simple, actually. All we have is a scalar being multiplied by a matrix. So I'm going to rewrite it as 4 times -3, 1, 2, -4, -1, and 5. So 4 times -3. I don't know why my matrix, my brackets, they keep looking a little bit strange. Okay, 4 times -3 is -12. 4 times 2 is 8. 4 times -1 is -4. 4 times 1 is 4. 4 times -4 is -16. 4 times 5 is 20. And that is the answer for number 1. Number 2, it's a little bit longer, still fun. I'm just going to rewrite, instead of C and D, I'm going to rewrite my matrices. So we have 2 times, well, C is 1, 2, -3, and 1, minus 5 times, let me just move this a little bit more. We have 5 times 5, 1, 0, 2. So as we worked on the previous problem, let's distribute this scalar first to each of these elements. So we have 2 times 1. 2 times 1 is 2. 2 times 2 is 4. 2 times -3 is -6. And 2 times 1 is 2. Minus 5 times 5 is 25. 5 times 1 is 5. 5 times 0 is 0. 5 times 2 is 10. And now we have this subtraction. I don't know why, but I like to just write it, each of the subtractions. If you can do it in your head, that's actually faster and better. But I just wanted to see how we arrive to that final answer. 2 minus 10. Okay, so we have 2 minus 25. 2 minus 25, that would be -23. 4 minus 5 is -1. -6 minus 0 is -6, and 2 minus 10 is -8. So there we have our final answer for number 2.